newly forged and spun part has a grain flow that goes in a much more centrifugal or circular motion, which gives you greater hoop strength, and because of the forged properties, gives you significant impact resistance. I've read numbers that are small, somewhere 3 to 4% in the hoop strength, which doesn't sound much, but when you're making rocket parts, every bit counts. We have, for a number of our customers, reduced the amount of input material that they were using in a previous process by, let's say, 9 times. So that's a significant material savings for them. Sometimes even more than that. We produce a part that has no seams, no welds. So if you were building this by making rings and then welding them together, all of those steps that needed to be done before are eliminated. It can be a lot faster than other processes because of those steps that are removed. AST is a one-stop shop, so we will bring the material in, forge it, and then form it and rough machine it. And so our customer gets a consistent input material. They don't have to try to figure out how to do new extra setups because of variations in the product. They get a consistent, clean product. Customers come to us and they say, we want to make a particular size or shape part, and they have particular specifications or performance that they want to meet. They don't have to tell us how to make it as much. That's where we're experts. We don't design the engines or the components themselves. What we do is design how to manufacture it. It's a consultative operation, if you will. And we share drawings back and forth, work on ideas and designs, and then ultimately advise what we could do and the value that we would be providing. It also produces a very, very consistently round part. So we have a number of parts. This one happens to have a bell shape to it, but we make cones and we make other tubes and things like that. And those processes produce a very round part. Other methods, customers have tried taking sheet metal, for example, and wrapping it and then trying to weld it. Well, if you go in a process that does that, first of all, you end up with different metal properties in the weld and then the body of the material. And second, the roundness of the part isn't as good. So we can produce a part that is more consistently circular, and we can produce varying width depending on what the customer wants. So we have control throughout the process of where the material is going. And part of the advanced part work is that we can flare both sides of the part. We can close pieces. We're able to operate over mandrels as well as do work in the open air and close the ends of something, as in making a seamless tank liner. So it really is quite an artistic application and a mixture of engineering and imagination. And so that is a constant push in the industry. Larger and larger pieces, being able to make them in a seamless and efficient manner. We make significantly large components, yes. So we're able to make parts that are 80 inches tall, 80 inches wide, and can even go larger. As the part gets larger and larger, you're removing a larger and larger volume of material, and so now customers move into the spin forming method as a way to reduce the amount of time that they spend machining, as well as the amount of material that they put in. They're also putting an immense amount of effort into developing new alloys and various items, doing various things to expand the art there. And so there's a lot of industrial demand for copper right now. That I don't think is going to go away. And so the need to use the material in a economical as well as prudent manner is a real demand.